We're going to do problem number 19 on page 481 in the textbook. This is an Avogadro's law problem. And it says if 0.214 moles of argon gas occupies a volume of 652 milliliters at a particular temperature and pressure, what volume would 0.375 moles of argon occupy under the same conditions? So let's first write down what we're given here. We are given that we have 0.214 moles, so that's an N. We'll call it N1, 0.214 moles. Moles, here we go. And we have a volume that goes with it. We'll call it V1, and that is 652 milliliters. And we have an N2, and N2 goes like this, 0.375 moles. Let's get that fixed. Moles. And we're looking for V2. Okay, and so Avogadro's law is the relationship between volume and number of moles or amount of gas, and it's a direct proportion. So when the number of moles goes up, the volume goes up as well, or we have this direct proportion relationship like this. We just write it as a proportion. The number of moles to start with, the volume they occupy, provided the temperature and pressure don't change, have to be equal to that same ratio afterward. Let's solve this for V2. So V2, we'll do that by multiplying both sides by V2. Oops. V2, and then dividing both sides by N1, that gets rid of the N1s, gets rid of the V2s, and multiplying both sides by V1. So V2, therefore, equals N2, V1 over N1, and those numbers from the givens, 0.375 moles. V1 is 652 milliliters, and N1 was 0.214. So when we do the math there, the moles are going to cancel out, and we end up with 1,140 rounded to three significant figures milliliters. Now we should check, make sure that makes sense. The number of moles went from 0.214 to 0.375. It went up. So we would expect the volume to go up, 652 up to 1140. Check. That's Avogadro's law.